Welcome to section 2.1. In this video, we are going to get an introduction into fractions, some different types of fractions, and how to convert between a couple different types of fractions. So with that being said, when we are describing the top number of a fraction, that is called the numerator, while the bottom number is called the denominator. So in other words, if we were to have the fraction, let's say we have the fraction 4/3. In this case, 4 is our numerator, and then 3 is our denominator. Is the denominator. So with that being said, let's go through the different types of fractions that we will mainly see. So this first type is called proper fractions. Now, proper fractions is when the numerator, the top number, is smaller than the denominator, the bottom number. So an example of that would be 3/4, or another example could be 7/10. Now these are proper fractions because the numerators are less than the denominators, right? Because 3 is less than 4 and 7 is less than 10. Now looking at improper fractions are essentially the reverse of proper fractions. So improper fractions are when the numerator is larger than the denominator or greater than the denominator. So if we were to actually flip these two fractions, we would turn those into improper fractions. So let's bring the 4 in the numerator and bring the 3 down in the denominator. Same thing here. Let's bring that 10 in the numerator and then bring that 7 down in the denominator. And this holds true because the numerator, the top number, in both of these fractions are larger than the denominators of these fractions. Now moving on to this thing called mixed numbers. So mixed numbers is essentially when we have a whole number or an integer next to a fraction. And I will get into what exactly a mixed number means in a minute here. So a mixed number could be something like 1 1/2 or 4 2/3. Now you may recognize these they're used a lot in the cooking recipes and stuff like that, so they are very applicable and very widely used. So for this first section, let's go through these fractions and sketch out a pie chart and use a calculator to calculate the approximate value of each fraction. So with that being said, whenever you want to sketch out a pie chart, you first take a look at the denominator. The denominator is how many pieces you're going to sketch out. So in this case, we're going to draw out 4 pieces. So let me draw out a circle here. We're going to split this into 4 pieces. And then the numerator here, the top number, tells us how many pieces we are going to shade in. So in this case, we're going to shade in 3. Uh-oh. There you go. So this here is what is called a pie chart. And this pie chart resembles this fraction. And the shaded region tells us how close we are to 1, you can think of it as. And this makes sense if we were to divide 3 divided by 4 in a calculator. I will give you a moment to do that. If you don't have a calculator near you, I encourage you to pause the video before you do that. And assuming you have given this a go, or you might have done this mentally in your head as well. Either way works. 3 divided by 4 is 0.75. Moving on to example 2, I encourage you to pause the video, sketch out a pie chart, and then do this conversion from a fraction to a decimal. So when you have given this a go, in this pie chart, we are still going to divide out 4 sections because the denominator is still 4. So we're going to go, and in this case, because the numerator is just 1, we are only going to shade in one portion of the pie chart. And now that we have that visual representation, let's do 1 divided by 4. Now you can do this in a calculator, or you can think about this mentally, right? Because we know that to get to 4, we have to add 1 4 times. So you can think of it as, okay, since we have 1, we can think of this actually as like a quarter. A quarter is 25 cents, and to get to $1, you need 4 quarters. So you can think of this actually as 0.25. And if you were to put that in a calculator, 1 divided by 4 is in fact 0.25. Now moving on to 3/6, I encourage you to pause the video and give this a try on your own. And assuming you have given this a go, let's sketch out the pie chart. So one thing that I do want to point out is our denominator has changed. So we're going to sketch out 6 pieces of the pie. So we're gonna go, I like to maybe kind of draw out an X. It's not an even X at all, but that is okay. And then draw a line down the middle. And because 3 is in our numerator, we want to shade in 3 pieces. We have 1, 2, and 3. So that is half the pie. And what we will find is that 3 divided by 6 is also 0.5, which makes sense. 0.5 is a half, and this pie chart also resembles a half. So that's what these pie charts are doing. They're showing us visually the value of the decimal. And taking a look at example 4, this one is a little bit different. This is actually our first example of a mixed number. So I encourage you to pause the video and try this one on your own before we work through it. And assuming you have given this a go, with a mixed number, essentially, we can rewrite this as 1 plus 1/2, right? Because a mixed number is essentially taking an integer, whatever that value happens to be. In this case, it's 1, and we're adding 0.5 to it. So I'm actually going to give the decimal approximation first in this problem, and then we're going to sketch out the pie chart. So 1, you can put this in your calculator, or you can think through this logically, right? So we have a value of 1, and we're adding 1/2, which is 0.5. So 1 plus 0.5 is going to be equal to 1.5. Now, to sketch this out visually on a pie chart, because we have the integer of 1, we're going to just sketch out a circle first, and then shade that entire circle. So this entire circle represents the value of 1. So we have an entire value. Good enough. And then we are going to actually have a second circle because of this fraction here. So we're going to have 2 chunks because the denominator is 2, or 2 pieces, I should say. So we're gonna go down the middle. And because our numerator, our top number here is 1, we're just gonna shade in 1. And that makes sense with this visualization as well, because we have 1 whole circle plus half a circle would equal 1.5. So now that we got some visual understandings of fractions, let's take a look at how to convert mixed numbers to a proper or improper fraction. So I'm just going to write out some general steps to do, and then we're going to work through those steps in these 3 examples below. So your first step, step 1, is you're going to multiply the integer with the denominator. And then in step 2, we're going to add the answer from step 1 to the numerator. And then in step 3, this is our final answer. We're going to put the answer, put the answer from step 2 in the numerator. And keep the denominator. Okay. Sorry, I kind of ran out of room there. But with that in mind, let's work through examples 1, 2, and 3. So for this first example, let's work through this together. And then in examples, once we get through example 1, for examples 2 and 3, please pause the video and try these ones on your own once you've seen the example before I go through them together, or before I go through them in the video. So with that being said, let's take a look at example 1. So our first step is to multiply the integer with the denominator, or in other words, the denominator is the bottom part of the fraction. So we're going to do 1 times 2. And then whatever we get from that answer, we're going to add that to the numerator. So in other words, this is our first step, this is our second step. So in other words, we have our first step, which is 1 times 2. And then our second step is to add a 1, because our numerator is 1. So we have 1 times 2 plus 1, and then we're going to take all of that divided by the denominator, which is 2. So, 1 times 2 is going to be 2. And then we're going to bring that plus 1 divided by 2. And 2 plus 1 is 3. And then we keep our denominator. That's our answer, 3/2. Looking at example 2, I encourage you to pause this video and try it on your own. And assuming you have given it a go, let's work through it together. So we're going to multiply the integer in the denominator. And then once we get that answer, we're going to add that answer to whatever is in the numerator. So we're going to have 3 times 4 plus 3. And you're going to put all that over the denominator of 4. So 3 times 4 is going to be 12. And then 12 plus 3 is going to be 15. And that is our answer. And then lastly, taking a look at example 3, I encourage you to pause the video and try it on your own. Now let's work through it together. We have 7 times 6. And then from that answer, whatever we get for 7 times 6, we're going to add 5. So let's write this out visually. We're going to have 7 times 6, and then we're going to add 5. And we're going to divide all of that by 6, our denominator. So 7 times 6 is 42. Then we're going to add 5, divide by 6. And 42 plus 5 is 47 over 6. Now, our last topic in this section is how to go the opposite way when you're given this fraction and how to go from this fraction to this fraction. So how to go from here to a mixed number. So that's what this question is asking. What about going from a proper and improper fraction to mixed numbers? Now, in order to figure that out, we have to ask ourselves the question, how many times does the numerator, oops, not the numerator, my apologies. How many times does the denominator, how many times does the denominator go into the numerator? Okay, so now that we got that, let's work through our first example. So our first example, we have 3 halves. And in this case, we have to ask ourselves, how many times does 2 go into 3? Or in other words, how many times can we multiply 2 before we go past 3? In that case, 2 goes into 3 once. So we are going to have 1, and then we have to ask ourselves, how many more, how far are we away when you multiply 2 times 1? So let me actually write this out. So when you do 2 times 1, we have 2 times 1, that equals 2. So we have to ask ourselves, how far is 2 away from the value of 3? In that case, we are 1 value away. So in other words, we have a remainder of 1. So once we get that remainder, we could now convert this into a mixed number. So whatever we have out in the front here, this is how many times 2 goes into 3 fully before we have remainders. So we're just going to pull that integer out, whatever that happens to be. In that case, it is 1. And then we're going to take whatever we have as the remainder and put that in our numerator, or our top number. So we're going to have 1 in our top number because our remainder is 1. And then we have to divide it by whatever we have in our denominator, and which in this case is 2. So we have 1 and 1/2. That is our final answer for example 1. And I just want to point out quickly here that if you notice, 3 halves is a problem that we converted to a mixed number. But also if you take a look at example 1 up here, we converted 1 and 1/2 to 3 halves. And then we did the same thing, just the opposite way. So we took this 3 halves, and we went the opposite way, and we got the same answer. So that's one way you can kind of like check to make sure that your logic is working, is to go like between the two types of fractions. So taking a look at example 2 and 3, I encourage you to pause the video and try this on your own. And as soon as you have given it a go, we have to think, how many times does 4 go into 15? Or in other words, how many times can we multiply 4 before we go past 15? In that case, we can multiply 4 3 times. So 4 times 3 equals 12. So we know our integer is going to be 3. And then from here, we have to ask ourselves, okay, how far is 12 from 15? And in that case, 12 is 3 places away from 15. So we're going to have 3, remainder 3. So now that we got that, let's write out our mixed number. So we're going to take this number here, we're going to write that out. And then our remainder is 3, so we're going to write that in our numerator. And then now we're going to take whatever we were originally given in our denominator, and just put it over the 3, or the remainder, and that is your answer. And looking at example 3, I encourage you to try this one on your own before we work through it. And assuming you have given it a go, we have to ask ourselves the question, how many times does 6 go into 47? And 6 goes into 47 7 times. So let me actually write that out here. So we have 7, and then we got to figure out a remainder. So in this case, once we do 6 times 7, we are going to get 42. And then once we get here, we have to ask ourselves the question again, how far is 47 away from 42? And that is 5 places. So we're going to have 7, remainder 5.